Today we're looking at LeetCode Problem 206, Reverse Linked List. Given the head of a singly linked list, reverse the list and return the reverse list. Here's an example where the nodes are equal to 1, 2, 3, 4 and 5, and then we reverse that and get 5, 4, 3, 2 and 1. The approach that we're going to be taking is called the iterative reversal of linked list. It has a time complexity of O of n and a space complexity of O of 1, and it's the optimal approach to this problem. Now let's walk through an example where we've given a linked list with nodes 1, 2, 3, 4 and 5. Step 1. Create a previous and current pointer with values null and head respectively. So here's our previous, and here's our current, which is pointing at the 1 node. Step 2. Loop over each node while current is not null, applying the following logic. Next is equal to current.next, current.next is equal to previous, previous is equal to current, and current equals next. So next is equal to current.next, which is the 2 node. Current.next is equal to previous, so the 1 node is now pointing at null. Previous is equal to current, so let's move that over to the current node, which is 1. And then current is equal to next, which is the 2 node. Then we go back up again, and we say next is equal to current.next, so we'll move next over to the 3 node. Then current.next is equal to the previous, so the 2 node is now pointing at the 1 node. Then we'll move the previous so that it's equal to the current, so previous is now pointing at the 2 node. And current is equal to next, so we'll move the current to then point at the 3 node. Then back to the top where next is equal to current.next. So next is now pointing at the 4 node. Current.next is pointing at the previous node, so the 3 is now pointing at the 2. Previous is equal to current, so we move the previous to point at the 3 node. And then current is equal to next. So the current is now pointing at the node with a value of 4. And next is equal to current.next, which is 5. Current.next is equal to the previous, so the 4 node now points to the 3 node. Previous is equal to current, so previous is now pointing at the 4 node. And then we move the current to the next, which is the 5 node. Then next is equal to current.next, which we can see is null. Current.next is equal to previous, so the 5 node now points at the 4 node. Previous is equal to current, so let's have the previous pointing at the 5 node. And then we set current equal to next. And we can see that next is null. And while current doesn't equal null, we're in the loop. So we need to break out of the while loop. And then finally, step 3, return previous. And that's it, the linked list has now been reversed. Thank you very much for watching, it's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Let's look at LeetCode Problem 206, Reverse Linked List in JavaScript. Given the head of a singly linked list, reverse the list and return the reversed list. Example 1. We're given a linked list with nodes 1, 2, 3, 4 and 5, and when we reverse that we get 5, 4, 3, 2 and 1. The second example we're given, we're given nodes 1 and 2, and when we reverse them, we get 2 and then 1. And then finally, we're given an empty linked list, where we return an empty linked list, or null to be specific. So there's 4 edge cases that I can think of. The first edge case was example 3, which is where we're given a empty linked list. In that scenario, we need to return null, and we need to make sure that our solution can handle that. The second example that I can think of is where we're given a single node linked list. So if you're given a single node linked list, obviously there's nothing to reverse, so you basically just return head, or return the linked list that was given to you, because there's nothing to reverse. A third example would be where you're given 2 nodes in the linked list, like example 2 here. So you just need to make sure that your code is able to handle this scenario. And a fourth edge case that I can think of is where you are given a linked list and all of the values are the same. So if we look at example 1, imagine each node had the value of 1, so it'd be 1, 1, 1, 1, and 1. You would want, basically, if this node here was 1, that would go to here. 4, if this was the 1, would go to here, etc. So you're just reversing the direction of the links. And you'd want to, I think that would be a good edge case to create a test for when testing your solution. So let's get into it. So we're going to declare 2 variables. We'll have previous, which I'll call prev, set that equal to null. Then we want current, which we'll set equal to head. Then while current, so we'll loop over the linked list using a while loop, while current. Then we'll declare one last variable called next. We'll set that equal to current.next. And then we'll set current.next. Current.next is equal to prev. Then we'll set prev equal to current, and then we'll set current equal to next. Then we want to return prev. And that, I believe, is the solution. So let's quickly just go over it. So current is the head, so that's the starting point of the linked list. So in the edge case where you're given an empty linked list, that's current is the head will be equal to null, so this will never run and will go straight to return prev, which is null. So that would be fine for that edge case. If current is not equal to null, then we're going to set next equal to current.next, so we're tracking the next item to go to in the linked list. Then we'll set current.next, so the current node that we're on, which in this scenario is head, we then set the link to previous. So the first node in the linked list is now pointing at null, which will be the end of the linked list. So we've rotated the link here, and then we update the previous to equal what current is, the current node that we're on that we've just rotated the link on or reversed. And then we update the current to go to the next node in the linked list. Then once the current is equal to null, then we'll break out of the while loop and we will return previous. So let's run that and see if it works. It does. Then we'll submit it, see if it passes tests. Which it does. It beats 100% for runtime and 44.65% in terms of memory. The runtime complexity of this solution is O of n, and space complexity is O of 1 constant, and this is the optimal solution to this problem. If you like the video, please click like. If you could click subscribe, that would massively help me and the channel out. And if you have any comments or any videos that you'd like me to produce in the future, please leave them in the comments below and I'll get right back to you. Thank you very much for watching and good luck with your coding.